So we're looking at the first question, and this is the order of the questions. So you're getting them in this order, and these will be the questions. Construct a frequency table and a frequency histogram. Anything that says construct, you can expect that that'll be a file upload question because this is all happening on Blackboard, right? Construct a box plot and state the 5-number summary. Find the mean, median, mode, all that good stuff. Determine whether a distribution is normal. Right? You'll have a choice there of whether you want to use the empirical rule or if you want to use the normal probability plot. And most people go with the empirical rule because they need it for other stuff. We'll go over that in a little bit anyway. Outliers, unusual values, finding z-scores, line of best fit, regression model, and interpreting a residual plot, or finding and interpreting a residual plot. Some of these questions will be fill in the blanks. Some of them will be short answer, and some of them will be the file uploads. What I always do is I include an 11th question that isn't really a question, it's a 0-point question that is simply for you to upload any supporting work that you might want me to see. So that's a case of like, you did a short answer question and you want me to see the supporting work just in case you get it wrong, I can still give you some partial credit, right? So it's not, those are not all or nothing situations, even though it may seem like that on the assessment. You're looking at every question, you have an opportunity to earn partial credit, even if you get a question wrong, right? So that 11th question that'll be there is going to be for you to demonstrate the work that I would need to see in order for you to get that partial credit. The testing policies, pretty straightforward stuff for the most part. The only thing that makes it different is, of course, what makes this class different than what it would be, and that is the remote environment. Right. So, but the standard things like you have a time limit. I changed my mind on the time frame. I'm going to make that 120 minutes, so 2 hours. Right. So that's how long you'll have to complete the assessment. I figure that extra 20 minutes, is probably necessary when it comes to the technology piece for those of you who are not really familiar and comfortable. Right?
Thank you very much. I was worried about that.
Yeah, no problem. I always make the right decision. Sometimes it takes me a little longer, but I eventually get there. Right? So let's see what's coming in on the chat here. Oh yeah. So okay. So yeah, that'll be 120 minutes. And I know there are some folks who get extended time through disability services. So for those folks, you would get whatever your accommodations say that you get, but also I would need the documentation from them. And nowadays it's usually them just sending me an email saying so-and-so gets these accommodations, FYI. So if you don't know what any of that means, then it probably doesn't apply to you. But if you know what the disability services office is all about, then I'm talking to you, right? The other things like using the bathroom and stuff like that's I think that falls in the category of common sense. When you're dealing with a time frame, a timed assessment, any time you waste is time that you don't get back. That's the definition of wasting time. So if you leave the test for 20 minutes, half an hour, then that's time that's going to count against you. Right. And I can't extend the window for situations like that. Right. So the time frame of the assessment will be extended for people only for extreme circumstances. And, everybody's definition of extreme is different, but mine usually falls into the realm of really, I don't want to say life-altering events, but like that kind of, it's skewed more towards that. Something really bad happened. I hesitate to give examples because I don't want it to become a self-fulfilling prophecy. But yeah, you just want to maximize the amount of time you have. So that means that you should take care of all your business before the test starts, and then also have any materials that you might need during the test. You don't want to be thinking to yourself, oh dang, I need I need a pencil. Oh, wait, now I need a piece of paper. Oh, it's all in the other room. You know, like you don't want to get down into that. So, so just have all that stuff ready before you get started. Right. As far as cheating is concerned, this is the spiel I give to all of my classes. But so I basically don't want people to think that I'm suspicious of anybody in this class. But it just so happens that every class that I've taught, there's always somebody who tries to do things that are not appropriate. So if you're considering taking the quote unquote easy way out and trying to manipulate the assessment in an inappropriate way, aka cheat, I'm pretty good at catching people who cheat, and I'm pretty good at like failing them for the entire course for cheating. So so yeah, I like liars and cheaters are two things that I like it galls me, you know, because I'm looking at the person who's busting their ass to make it through and to earn their grade, and then for somebody else to come along and cheat their way through, not on my watch. Okay, so like I'll make it a very uncomfortable experience for anybody who pulls a stunt like that. That being said, I've had mixed. I've had pretty good results. I mean, even I think I handle it the right way. Even when I do end up failing a person for the course, because I had a student that I had to fail for the course once who ended up taking my class again the following semester. It's like, I didn't have anything against you. It's like that. You're a great teacher. I just made a bad decision. I paid the price, and now here I am again. I'm like, okay, well, that's a very mature way of handling it. And he ended up getting a nice grade the second time around. So, you know, like, people make mistakes, but just understand that this is a mistake that will have serious consequences. Right? So don't cheat. I would say that in these uncertain times, there's a lot of gray area where it's like, is that cheating? I'm not sure. Am I allowed to do that? I'm not sure. If that thought crosses your mind, just ask. You know, the student in the other class asked a question and I answered the question. I think maybe some of you are wondering the same thing. Like, notes, are notes fair game for this test? Can I refer to my notes? The answer is yes, because I look at that as a policy that I don't have a chance in hell of being able to enforce. So if I were to say, no, you can't use any notes, how would I know? Right? So I designed a test that will be, you know, challenging, you know, like not too hard, a fair test. The notes, will they be useful for you? Sure. Why wouldn't they be? But are you going to be able to go into your notes and copy down a solution word for word and use that as, you know, like your way of taking the test? No, like, you're going to have to still know your stuff. You're still going to have to do the work. Just, you're going to have the resource available to you. So like that's fine. But any other questions along those lines are questions that should be asked. So is it okay if I do this? Like, one thing that it's not okay to do is you shouldn't be getting help from any outside sources, like people. Like, you shouldn't be contacting other students. You shouldn't be communicating with a tutor or whatever, another teacher or anything like that. Like, it should not be anybody taking the assessment other than you. All right. So just keep that stuff in mind. All right. The environment, these are suggestions, you know, like, I mean, can you technically have music on and still concentrate? I'm sure you can. I've found that the people who are blaring music and watching TV while trying to do math tend to have less success because their concentration is divided. But if you're the exception to that rule, then by all means, that's not going to bother me. But yeah, you kind of want to have it be a testing environment, you know, a quiet environment where you can concentrate. I mean, I think that makes sense, but, you know, everybody's different. For the Zoom, so the way Zoom is going to work is in the beginning of class, everybody's going to sign in to Zoom, and I'm going to present the test. right? So that'll be me giving any last minute instructions, tips or words of encouragement, that kind of thing. And then after that, I'm going to leave the Zoom open so that if people want to stay in, emphasis on want to stay in the Zoom, just in case any questions come up, you're more than welcome to do that. I'll have the Zoom on, and they'll be there. You'll also have the option, because I know technological resources are what they are, you'll have the option of signing off of the Zoom meeting so that you can work independently. If you do that, again, the Zoom meeting will still be open so that if you realize after the fact that you have a question, a clarifying question, then you can come back into the Zoom and ask your question, right? Because, you know, sending emails and remind messages and stuff like that, it's good strategy. Like if you have a quick question, you want to send it on Remind, that's fine, encouraged even, but you also run the risk that I'm not going to notice it. If you come into a Zoom and ask a question verbally, I'm going to notice, right? So that's my recommendation. The one little consideration that I'd ask from you is that if you do come back into the Zoom after leaving it, just be mindful that there probably is going to be other students that are still in the Zoom that just chose to stay. So if you come into the Zoom guns ablazing saying, "Hey, I got a question," blah blah blah, you're probably going to scare the crap out of a bunch of people, right? So just try to kind of like gently make your way into the meeting. All right. Okay, so we got a question.
I have a question too.
Sure.
Yeah, it's the first time that it's going to be for me to go online and do the test. So I have the Desmo. I tried to download in the computer, but it didn't work. So I only have it in the iPad. And you say we have to work with the Desmo, which is great. And but to show our work, we have to do the screenshot and send you by email. How can I connect the iPad?
In the assessment on Blackboard, there'll be a button for file uploads. Okay. So when you start the test on Blackboard, it'll say for a particular question that it's a file upload.
Oh, we have to go to Blackboard to take the test.
Correct.
Oh, okay. Didn't know that. Okay.
Yeah, it's all set up through Blackboard.
Great. Makes sense. All right. Thank you.
No problem.
Professor?
Yes.
Quick question about Remind. So I know when you send a message, it goes to everyone who signed up. But if we send a message, is it doing the same thing or it goes straight to you?
Straight to me.
Okay.
Unless you take the step to make it go to everybody. But I'm pretty sure I didn't give students that permission. So it defaults right to me.
Okay, thank you.
No problem. All right, so that's your little preview of the assessment, the test, and really, it's like you got to kind of think of it as like, all right, it's an ordinary test. It's what a test would normally be. It's just how I'm going to submit my work that's going to be a little different, right? So if you have that in mind, it becomes a little less daunting, a little less terrifying. But yeah, it's still a test. So if you do your preparation and you come to the test with that preparation, then you're going to be fine with the content. And if you get jammed up on the technology, I'll help you with that, right? Because that's why I'm leaving the Zoom open, so that people, if they get jammed up on the technology piece, you know, how to navigate Blackboard, I can help with that, right? So that's where my brain kind of takes me. So that's what I'm offering. Right. What I wanted to do now is
Wait,
just
Professor, I have one more question. So
Sure.
in the test, do we have the option to like navigate between questions before we submit?
Yeah,
it?
I left it so that you'll have access to the whole test the whole
Perfect.
time. Right. So what I did was I took one of the reviews from the practice set. I just blanked it out, and I figured I would just go through this with you all. Right. So I think it's a good opportunity for us to refresh our memories on some of the older topics, and it's also a good idea to just see what a test looks like and go from there. Now, one thing I'll say is that This actually was not a real test. This was a review that I designed for one of the other practice tests. That's why there's so much data. You're not going to have this much data on the test, all right? And in fact, I might even, yeah, you know what? I might even I'm going to trim this down just to make it more manageable. I'm going to get rid of the 2005 information. I'm just going to stick with 1970. So I'm just going to put a big old X through this as soon as I get my pen. So, yeah, we're just going to get rid of this, and we'll just work with 1970. So I'm just going to change some of the problems. All right. So, the first question, create a frequency histogram with at least 5 intervals for the year 1970. That little caveat there of at least 5 intervals is, it's a wise ass defense, because what I've had in the past is people, they would create one interval from 0 to 300, and they'd put all the values in there, and it would just have 1 bar. So I want to kind of force it. I want to force your graphs to have more than 1 bar, right? So I'm looking at the lowest value in the data set here being 13, and the largest being 206. So you can break this up any way you want. You can go by 10s, you can go by 20s, you can go by 50s. 50 should get the job done. It's a nice kind of balance between having enough intervals, but also not being so overwhelming. Right? So we're looking at the class values or the intervals that are synonymous. Right? So I'll just say intervals. And the corresponding frequencies. So I'm going to make my intervals go from 0 to less than 50, and 50 to less than 100. So that allows us to get very, very close to those values, but not actually touch them. Right, so those will let me get to 49.99999 whatever, but I'll never actually get to 50 in that first interval. Right. Then we have 100 to less than 150, 150 to less than 200, and then 200 to less than 250. All right, the data, so that's 5 intervals, so that's great. Right? If I had less than 5 intervals, I would have a problem. Now, it doesn't matter if there's only going to be 1 value in that last interval. That's irrelevant. Right? I got 5 intervals. That's all I care.
Why do you write the interval as like 0 to less than 50 or like less than 100? Why don't you just do it to like 49 or 50?
Because this allows for all the decimal values between 49 and 50 to be included.
But we're not even working with decimals.
That we're not.
Make a difference. Oh, okay. All right.
So first interval 0 to less than 50. So I'll make little cutoffs here. Then we have 50 to less than 100. Then we have 100 to less than 150. And 150 to less than 200. And then that's it. All right, so we're just counting up the number of values in each interval. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8. Then 3. And then finally 1. All right, so that's the hard part. When you create a frequency histogram, that's the toughest part, the part where you come up with the intervals and the frequencies, because it's an eye test. you know, you got to count up all the values. It's aggravating, it's annoying, it's all that stuff, right? So, and we'll have to type all this data into the calculator in a couple minutes. So that's even better, you know, better as in not better. So we're going to create the graph. It's going to max out at 12. So you can go by ones, but you could also skip around here if you want and go by twos. Maybe I'll do that. I'll go by two. 2, 4, 6, 8, 10, 12. And then I just want to set up my my intervals. I got 5 of them. Got to label it up properly. So 0 to less than 50. 50 to less than 100. 100 to less than 150, and so on. All right, so we have those values. We also need a label for the axis. So I'm just going to move this up a smidge so I have a little room. And the label could just simply be intervals. So intervals and the corresponding frequency, I just put the letter F. That's perfectly fine. All right. So then I just need the numerical frequency. So 7, 12, 8, 3, and 1. All right, so 7. Let me go all the way up. Oof, rough. 12, 8.
Wait, you got your frequency values by counting how many times the numbers fall into the interval, right? Like for
Correct.
the entire graph?
Yep.
Okay.
All right, so 7, 12, 8, 3. I'll just put the 1 on the outside. And that's our histogram.
I know this is personal preference, but are we allowed to say if you want to use the format of 0 to 49 and then 50 to 99 on the test, could we do that or in our work? Or
If you wanted to do, say it again, sorry.
if we wanted to keep our own format, so I know originally we learned it as 0 to 49 instead of the less than. We just
Oh,
in our work, or,
yeah, you're better off with the 0 to less than notation, but
all right,
either way is fine.
okay.
Turn this off. I'm getting some stray marks here.
And when we do this for the test, doing a sketch such as this in the tool of our choice, even if it's not Excel, is acceptable?
Doing this, yeah, exactly. Yes.
Got it. And you wouldn't expect it to be a cumulative histogram, right?
No, it's just straight up histogram.
Cool. Thank you.
Right. So on the next page, we get
Yes, sir.
into the box plot and all the summary stuff. So what we're going to do is, before we go to that next page, type in all this data so that we have it ready to rock and roll. Now, when you do it
Professor, I have a question.
Sure.
So, the histograms have to be done in Excel or like in Desmos. Like, what if I wanted to do them like by hand? Would that not be accepted as work or?
No, you can do it by hand.
Okay. Okay. Just wanted to make sure. I got nervous for a second. Thank you.
So if we do it by hand, do we just submit a photo? Like, should we attach it to the end of the test or?
It'll be a file upload question. So
Okay.
that question will say, upload an image of your work.
Okay, the same way like Blackboard does, right?
Yeah, exactly, because it is Blackboard.
Oh, okay, yeah. Thank you.
No problem.
And sorry, but what you clicked here was just new table in Desmos, correct?
Correct, yeah. So the plus sign, the new table, and then I'm just typing it into X1. We won't need Y1. Okay, so it took a little while, but we finally got them in. Now I just got to do a quick double check and make sure I got them in correctly. 45, 45, 40, 119, 108, 104. It's pretty rare that this happens, but it has happened before because when you take the test, you'll see that it's the same data set used over and over and over again. So you type in the data the one time, and then you keep referring back to it. What that means, for convenience, that you only have to type in the data the one time, which is great. But the con to that pro is that you screw it up, you're going to get every frigging question wrong on the test, right? So double, triple check. If you're going to be obsessive over anything on the test, be obsessive over data entry, right? Because that's really, I mean, based on some of the stuff that we're going to do, in a lot of ways, it's the only way you're going to screw it up, right? So,
Professor, is this an XY table?
this is the XY table, yeah.
I do not have that on my GeoGebra. I can't.
Desmos,
Oh, so do it in Desmos.
yeah. GeoGebra, it'll work. It's just not as user friendly. So if you wanted to try to do it on GeoGebra, you could do it, but it's not as user friendly.
Blackboard's gonna like let us open other tabs like during the test.
Yep.
So we could do a
Oh,
split
okay.
screen with the Desmos too.
Yep.
Okay. Oh man, this is.
Sorry, after you entered the information, can you scroll back up to the tables where you were splitting them? Oh, it just truncated the table. You didn't do anything there.
Yeah.
Got it.
So the second question, create a box plot and list a 5-number summary. Well, Desmos will give us the 5-number summary. We're on the hook for the box plot, right? So, I mean, there are workarounds, but this is the most user-friendly way to do it. So under stats, we select stats, and then we input X1. You know, type in the X1 so that all those values are referred to so that you can have the appropriate information. Probably goes without saying, but why?
Professor,
Yes.
can you show where you saw the stats? Because I'm trying to do it. I don't see it.
So you go into function, stats menu. It's in the bottom right-hand corner, right above IT test.
Oh, okay, I see it. Okay, function stats. And which one did you press after that?
You type in X1, and then it brings up everything you need.
Okay, no, I don't think I did it right. So I pressed the functions button
Right.
and I pressed stats.
So functions, stats, then you type in X1.
Oh, you mean the actual stats? Does it, okay, I didn't see there was, when you go to stats, there's one that says stats. Okay.
Yes.
I just seen the menu. Okay, now I'm with you now.
Gotcha. All right, so I'm just going to make a note of what the 5-number summary is. So we got the minimum, the Q1, median, Q3, and the max. And again, we're only referring to 1970 here, so change this. So 13, 55, 83, 128, and 206. Now, when we create our box plot, we're going to create a scale spanning from the lowest to the highest in even increments, right? So I'd look at this and I'd say, okay, 13, well, what's a nice number that's around 13? You could say 10, but I would even go further and say 0. So 0 on the low end. And then 206, well, that's close to 200. If I wanted to go by 25s or 50s, maybe I'll go by 25s, then I would go up to as high as 225. So I start my incrementation. So 25, that's probably too wide of a spacing. 50, 75, 100, 125, 150, 175, 200. And of course, I always do this. I cut myself short here. So let me extend. Oops, a little wonky there. So I can get my 225 in there, then I can just kind of move this down a little bit. Close enough. All right. So I have an evenly dispersed scale. And what I'm going to do is I'm going to plot these values in some space that I predetermined above the line. All right. It gets a little too messy if you do it on the line. So I do 13, which is a little bit more than halfway between 0 and 25. So just ballpark that. 55, going to be a smidge to the right of 50. And again, it's just ballpark estimates, 83, 128, and then the last one is 206. All right. And so then we pop a box around the middle three. And extend out to the extremes. And there's your box plot. Right. It's kind of like a constellation though, where it's like, really? I'm not seeing that. That doesn't make sense. You know, it is what it is though. So you just got to know that you're boxing the middle three, putting a line through the median, and then extending out to the extreme values. The quality of this line is bothering me. Oof. Mm. A little better, I guess. All right, so we got that. Box plots in the books. Again, for the year 1970, determine the mean, median, mode, range. Well, we got the median, 83. That's something. We already have the data in, so we can get all the other stuff too. So that's good news. Some of them aren't built into the function, so we have to figure it out on our own. But like for example, the range. I'm just going to hop along to the ones that are easily obtained right now. The range is max minus min. So that's 206 minus 13. That's 193. The mid-range is the average of the max and min, so max plus min over 2. So that's 206 plus 13 over 2. So that's 219 over 2. That's calculator time, I think. Probably not. It's 108. What was it? 109.5. Yeah. But that was the one when I first introduced that concept, the mid-range. I mentioned that you need to make sure you study that one because people forget, they don't study it, and what ends up happening is they say, okay, well, I know the range is max minus min, mid-range probably half of that, so 193 divided by 2, that's not correct, right? So you got to be careful about that, right? The mean, variance, and standard deviation we'll get from Desmos, but the mode, most frequent value, we get that right from the data itself, so we go back to that. and just look for any repeated values. And then once we find repeated values, identify the ones that are repeated most frequently. All right, so it looks like I got these 3 values, and I can erase the highlights on the other. So 45, 55, and 145 are all repeated. That doesn't necessarily make them the mode. Because they occur more frequently than every other number, that makes them the mode. All right, so we have 3 modes here, 45, 55, and 145.
If they're repeated the same number of times, is it 3 modes or is it no mode?
That's 3 modes.
Got it. Thank you.
No problem.
And Desmos has no way of doing that for you. I tried mode
It-
and it interpreted E as a separate character.
Oh, yeah, there you go. All right, so for the mean, we want, under our stats menu, I mean, you got all these different options. Odds are you're going to find the one that you're looking for. You know, so we got the mean. We want it to be the mean of X1. So I had to hit the back arrow there in order for it to come up, but it came up. So 90.323. All right, so just be prepared to go to the 3 significant digits. So 3, most of the time that means 3 decimal places, but it technically means the first 3 non-zero decimal points, right? Decimal places, I mean. So in this case, it means 3 decimal places. So I can enter, I can lock that in. For the, I could find variance a couple of ways. Most people just find the standard deviation and then square that result. So we could find the standard deviation, again, of X1. That would be 51.156 is what it would round to. And then you could take that value and square it, because standard deviation is the square root of variance. That's fine, but you also have, I mean, it's right there, it's built in. They have a variance function. So the variance would be 2616.892. Now, again, if I were to take my 51, so standard deviation, you know what, I'll just duplicate it. Let me just do it that way. So duplicate, edit it, and then just square the result. You know, take my standard deviation and square it. You could see that it ends up being the same value. So it either way, but like I said, they have a function built in, why not use that, you know? But that var stands for variance, so it's the same thing, all right? So that's, couldn't help myself. I kind of feel like I need to teach while doing this. So I'm just checking the chat. Oh, for standard deviation, it's the standard deviation function, all right? So the question was, how do you find standard deviation? You just go into function, under stats, you see an option that says stdev, standard deviation. Type in the X1, and there it is. All right. So we have this problem squared away. It's all accounted for, and it's all based off of that same data. So that's what I was saying before. If you screw up on the data entry, it's all over. You know, it's the end of the world. All right, so we got to be really careful. So let me make this a 1970. And again, 1970. All right, so both of these problems rely on information that we've kind of already determined. So it's really just a matter of crunching some numbers. Most people, I mean, it says here that this problem says use the empirical rule to determine if the data for 1970 follows a normal distribution. But on the test, it'll say just determine whether a distribution is normal. And then you could use the empirical rule or the or the normal probability plot. Most people go for the empirical rule, so that's the technique that I'll go over. Because the other way was the really complicated. It involved the z-scores and finding areas related to the z-scores. It wasn't really a user-friendly process on Desmos, so I encourage you to focus on doing it using the empirical rule. It's going to be a much easier experience. So, and the empirical rule is the 68, 99, 95, 99.7% rule. So we're looking at, we have to perform 3 calculations potentially. X bar plus or minus 1s, X bar plus or minus 2s, and X bar plus or minus 3s. All right, these are all the computations that we need. Let's see a question coming in. Yeah, I'm recording, yes. So we have the mean. We discovered it up here to be approximately 90.323. And we have the standard deviation, approximately 51.156. All right, so we don't need a special function in the calculator in order to figure these computations. We're just going to do it using rote computation. All right, so we're looking at 90.323 plus or minus 1 times 51.156. All right, and that's going to give us an interval. What we do is we perform the subtraction first, and then we take care of the addition. All right. So when we do the subtraction, we'll get a result, and we'll go there, and then comma, whatever we get for the result of the addition step. Right, so that's all happening in Desmos. Now you could work in general terms if you want. You could actually say X bar, mean of X1 plus or minus standard deviation X1. I'll show you both techniques, because some of us are savvy enough with the technology to be able to handle this, and some of us are like, oh, that's too much, I don't want to do that. All right, so what you would do if you wanted to do it, let Desmos really do all the work, is you would select the function mean, type in X1, because it knows what that is, minus, and then select standard deviation, also X1. So that would be the X bar minus 1 standard deviation. And then if you wanted to do the plus, you select that little gear, see that little gear next to the downward arrows. It gives you the option to duplicate a command, the little 2 pages. Then tap on the thing that you just duplicated and change the minus into a plus. All right, and so you get the 2 endpoints here. I'll jot it down because the next way is going to give the same result. So 39.167, 141.478. All right, but let me show you the ordinary way of doing it. You would just type in 90.323 minus 51.156, all right, and that rounds to the 39.167 that we just came up with. You could also do the duplicate function, but it's not really that lengthy of a set of values, so you could just type it in again too. All right, so you get them that way also. Oh, this went to 479 instead of 478. Not a big deal. I make multiple answer keys to allow for differences in rounding and such, so you wouldn't have to worry about that. Anyway, I'm looking at these 2 numbers and also the original data set to see if about 68% of the data falls in that interval. Right? If it doesn't, then the next 2 computations become irrelevant. All right, so what I'm going to do, just so I don't have to flip back and forth, is I'm going to just snag this and bring it over to the previous page. Just kind of pop it down on top here. Just so I can refer to it. I'll get rid of all this stuff because it's just going to get in the way. So I'm going to look at any value that's bigger than 39.167. So the cutoff would be here, but also less than 141.478. And so all I'm going to do is I'm going to count up the total number of values in this interval, and then I need the total number of values in the set. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 31 values in the set overall, 20 of which fall in that interval. All right, so I'm going to come back here and we get 20 values in the interval. "31 values overall. All right, when I divide the two, so I'm just doing 20 divided by 31, I get about 0.645, all right? So that's approximately 64.5%, which is not close enough to the 68% to say that this is a normal distribution. So 64.5%. Let me just move this down. So then I don't need this and I don't need that. This is not a normal distribution because X bar plus or minus 1s does not capture approximately 68% of the data. It's close, not close enough though. All right, so let me look at the chat. I see a couple questions. Oh, the duplicate? Sure. All right, so to make a duplicate, let me just get rid of the ones that I don't need. So let's say I just wanted to duplicate this expression just to change the minus into a plus. I hit that little gear next to the downward facing arrows. That brings up this display. And so I just tap the double page icon for the thing that I want to duplicate. And then I tap on the expression again. So right on the expression, and then I can go back and manipulate it in any way that I want. The general rule of thumb for the 68% is 2 percentage points. Right? So if we got a value that was between 66% and 70%, then it would have been fine, but it wasn't. So we stop there. All right. Then we talk about outliers or unusual values. This, it's separate on the test, but I have it here as a combo question. But it's still material that we need to go over. Fortunately, again, just like I've been saying, we've already put the data in. So we already have that information. So let's tackle the outliers first. And then we'll get on to the unusual values. So the outliers are any value value or values that fall outside of the interval of, well, it's LQ, but Desmos presents the information differently. So I'll use Desmos language here. Q1 minus 1.5 IQR times the IQR, comma Q3 plus 1.5 times the IQR.
Professor? I was just about to ask you, do we have to memorize that?
No, you have access to your notes.
Wonderful. Thank you.
No problem. So IQR is Q3 minus Q1. So we got, it's on this page, we got it, but it's been a while now. All the information we need is right up over here. So I'm just gonna copy this and bring it down. So I only need really the Q1 and the Q3. So we have that information. I also need the IQR, which is the difference between the two. So 128 minus 55, 73. So we're looking at 55 minus 1.5 times 73, comma, 128 plus that same thing, 1.5 times 73. All right, so we gotta crunch these numbers. So 55 minus 1.5 times 73. So that's a negative number. I don't recall seeing any negative numbers on that list. All right, 54.5. So I'm not worried about having an outlier on the low end. On the high end, I think the largest number was 206. All right, so we'll crunch this and see if we get anything in that neighborhood. 128 plus 1.5 times 73 is 237.5. All right. So from this, we can conclude that there are no outliers. All right.
What would happen if we put the multiplication sign instead of the point? Would it work just the same in Desmos?
If you use the multiplication sign,
Yeah.
like, are you talking about the notation?
Instead of like, you know how you did like 1.5 times 73
Yeah.
and you used a dot? Instead, she can still use the X, right? Like multiply. Yeah.
That's what I'm used to. If not, then.
Yeah, well, that's the issue, because even when you hit the X on the screen, it still brings up the dot.
Okay, okay, perfect.
Yeah, so it should still work.
Mm-hmm.
I think you could use parentheses too if you want.
Yeah.
Should, yeah. So just to make it look more like what it looks like on paper. So we have no outliers because there are no values that fall outside of this interval. All right, every single value in that data set is in between the negative 54.5 and 237.5. The largest value that we had was 206. So we don't have any outliers. Now what we're doing is we're looking for unusual values. Now, this is where getting a decent handle on Desmos becomes, it's not a deal breaker if you're not very proficient with Desmos, but it becomes a time saver, right? Because any value that falls outside of the interval of unusual X bar plus or minus 2s, right? That any value that falls outside of that interval is considered to be unusual, right? And so it's the same numbers from the previous problem. We had 90.323 plus or minus 51 or 2 times 51.156. 156. All right, so we have to crunch these numbers, but we've kind of already done that work, right? Because I can look up here and I can say, all right, well, why don't I just duplicate this, right? And so when I duplicate it, I could just tuck in at 2 times. And so I get my low bound, negative 11.989. Then I can duplicate that and change the minus into a plus. Okay. So any value that falls outside this interval is going to be considered unusual. So I can go back to my data set in here in Desmos, or I can go back to the original printed data set. I know, again, I have a negative lower bound, so I'm not worried about an unusual value on the low end. But on the high end, I see that I have 2 numbers that are each bigger than 192.635. So we can conclude that 197 and 206 are unusual values. All right, so no outliers, but we do have a couple of unusual values. Right, and you know, without getting into the context of the data, what does that tell us? It just tells us that we have some values that are so big that they stand out. But when you get into the context, you realize that these are alarming values. Right? So then on the next page, we have a couple of problems that we can toss here because, well, one of them I'm going to change and the other one I'm going to toss. So, because we've already tackled the normal distribution question. We've actually done this question. So this one I can get rid of. This one, I'm just going to make it Togo in 1970. So it's asking us which has higher infant mortality rate relative to its year, Iceland in 1970 or Togo in 1970. Right. So it's a Z-score question. Justify your answer. Now it's a flawed question the way I have it structured because they both have the same mean and standard deviation. So just simply looking at the numerical values would be enough to find this answer. But I wanted to take you through the Z-score approach, right? 64%. Oh. Yeah, so it's 64.5%. It's the 20 over 30 over 31. And then, you know, you multiply that by 100, get it as a percent. That's usually good enough. Yeah, so like I said, it's a flawed question, but look, we still need to go over the concept of the Z-score, so we can still make it work. We do need the mean and the standard deviation. So it's the same mean and the same standard deviation, 90.323 and 51.156. So X bar, 90.323, S, 51.156. So we need the value for Iceland and the value for Togo. So I go back to my original data set. Iceland was 13. Togo was 128. Right. So we already know which one has a higher one relative to its year, but we're looking at the Z-scores here. I already forgot the numbers, 128 and 13. So, all right, so what we're going to do is we're going to compute the Z-score for Iceland, and then we'll compute the z-score for Togo. All right, so 13 minus 90.323 divided by 51.156 and then the same thing just with a 128 instead of a 13. So we just have to crunch these numbers and we'll get the z-scores. These are going to give us the number of standard deviations that these scores are away from the mean. So 13 minus 90.323 divided by 51.156. And we get, and for rounding, negative 1.512. And again, the duplicate function is pretty solid here because I can duplicate and then replace the 13 with 128. And we're looking at 0.737. All right. Now, again, we already knew that Togo had a higher infant mortality rate than Iceland, but this really shows, it really emphasizes it because this is showing that Iceland is almost, I mean, if we're rounding, it's getting close to being an unusually low value, right? It's getting close to 2 standard deviations below the mean. And so, you know, when you're thinking of infant mortality, that's what you want. You want to have a number that's so low that it's unusual. Like, what are they doing right? You know, you don't want to be average or above average. Right? So that's an important realization. So therefore, we would conclude that Iceland, higher or lower? Higher. Togo has higher infant mortality rate relative to 1970. All right, so relative to the data in 1970. All right, but relative to 1970 is just fine. We got in the chat here. Oh, that sheet is in the same extra practice and review folder on my website. Okay, so it's basically the same place where this file is. Okay, so that kind of, I mean, if we go into the breakdown, you can see that we did the histogram, we did the box plot, we did all this stuff. We did the normal distribution, outliers, unusual values, these scores for relative standing. So the only things that are left are the lines of best fit and regression models and such. So that's, you know, we're in the home stretch here because they get another couple of problems that'll take us through that, and then we'll be there, right? So number 8, it's a fresh set of data, so it's up to you if you want to start a new Desmos, or if you want to wipe this one out. You know, like whenever I type a lengthy data set into my calculator, it's like I'm loath to wipe it out, so I tend to save it. But saving it requires you to log in and all that stuff. But that's all right. So this is a review. And then a new blend graph. All right. So, oh, I got a question in the chat. Oh, no problem. So here we have a bivariate data, so 2 data sets. Following represents observed durations of total lunar eclipses between 2001 and 2010. Data were obtained, sounds weird, from this website. So plus table, just to get us started. We type in these values. We got a 1, we got a 3, we got another 3, a 4, another 4, a 7, another 7, an 8, and a 10. All right, then we have these disgusting decimals to go along. So 3.4, 3.233, 3.517, 3.383, 3.65, 3.683, 3.53, 3.25, and then the last one, 3.483. All right, quick double check. Looks good at first glance, so we're good there. All right, so then the question, determine the curve of best fit for the data set. So this is that cookie problem that we did, where we had to tackle linear, quadratic, cubic, quartic, exponential, and natural log. All right, now I can tell you that on the test, I'm not going to ask you to go through all of these possibilities. So I'm just going to ask you to do 3 of them, right? So it'll be, actually, honestly, I can't remember which 3 it'll be. So I'm going to cheat here, and I'm just going to look really quickly before I say the wrong thing. No, hit the wrong thing. Already hit the wrong thing. Quadratic, cubic, and exponential. So in the interest of managing our time wisely, those are the ones that we'll focus on now. All right, we'll just we'll ignore the other ones. All right, we've tackled those together, but it's the question of, what's the best use of our time right now. All right, so we will need the R-squared values. All right, that's the coefficient of determination. That's honestly, when people tackle this kind of question on a test, it's things like that that throw them off. They're like, what the heck is the coefficient of determination? That's the R-squared value. So we just want to know which has the best R-squared value, as in which one is closest to 1. All right, so we're typing in Y1 equals what we're going to put in the model for quadratic. So A x1 squared plus b x1 plus c. Little tilde thingy. Wherever the heck it is. Oh, there it is. There you go. All right, so we have the R-squared value, which is just a dreadful R-squared value, 0.07449. So 0.74, well, I could just write the whole thing. Not really that much. All right, so I could do that. And then if you want, the duplicate becomes pretty powerful here, because then I could just go back and change my power to a power of 3 for the cubic, then power of 2, just make the adjustments on the fly. It's a little bit easier. Cx1 plus d. All right, and so we get 0.07456. All right, so that's only slightly better. The next one, there really is no benefit to doing a duplicate. Look at the chat here. It's a huge value. I'm not sure I understand. But the decimal value or the equation itself? Oh, that's the regression model. That was what we covered the entire last class. Yeah, that's referring back to the original data set, which has values in X1 and Y1. Right, so. It's constant. Not necessarily. Yeah, Y1 is X1 and Y1 are two variables that are related to one another. So we're looking at these two variables and whether or not a quadratic model will be the best fit or an exponential model, cubic model or an exponential model will be the best fit. So then we're looking at exponential now, so y1 tilde. We just want to put it in the appropriate exponential form. All right, so it's, if you go, let's see if I have it handy here. Wrong class. I got like 100 things open here. Course notes stats. See if I have it handy, then I can at least talk about it.
Professor?
Yeah.
So sorry if I forgot what you just said, but so can we use the regression model that we made a few classes ago and just type in new values for this?
Yep.
And we just type in whatever was in that little chart that they gave to us, right?
Exactly.
Thank you.
No problem. Yeah. So this is right. This is the notes that we took in that during that lesson. And if you just refer to this, if you need the quick refresher on how to put stuff in, then this is probably the best place to go because it gives you each of the different models. And you can see here for exponential, for example, y equals a times b to the x, right? As opposed to y equals mx plus b for a line and so on, right? So that should be somewhat helpful.
Professor? Just to clarify for myself, when you type in the equation in Desmos, for example, where it's CX, you have to remember to put the 1, right?
Yes, exactly.
Okay, thank you.
No problem.
So would it be safe to write it when I write the equation by hand, to just write it to remind me, or it doesn't apply if I'm doing it, if I was to do it by hand?
If you're doing it by hand, you could write it any way you want. X's and Y's, X1s, Y1s. But in Desmos, that's the only way it understands it.
Thank you.
So 02146 is what we get for the exponential model. So none of these are lighting the world on fire here. The best of the bunch appears to be cubic. So that's our winner because that has a value, R-squared value that's closest to 1, right? That being said, it's not really that close to 1, right? So none of these are really a good fit, but this is the best of what we have, right? So we determined the curve of best fit. We took care of that, and we justified with the coefficient of determination. So that's our answer to part A, I should say. And then for part B, estimate the duration of a total eclipse in the year 2017. Well, so that means I need my equation, right? So I got to grab my cubic equation. And from there, I want to just evaluate it, right? So I'm going to jot down the equation here. Rounding is okay. I mean, you see these decimals are pretty nasty, so it can get a little funky. But there is another way of handling this, and I'll show you both ways. It's slightly different, but if I write this as y equals ax cubed plus b x squared.
I have a quick question.
Sure.
At the end of the enter of the formula, should I press enter and they will come up with all the information?
Yep.
Mine is not coming up with anything and I pressed enter.
Did you type in x1 and y1 and?
Yes, the table is there. All the numbers are in and I pressed enter and nothing is coming up.
So you typed the commands exactly the way I typed them?
Yes, I did. Unless I missed something, I don't know.
Yeah, that's the issue. I think maybe you did miss something because it would work if you typed it in exactly. So like, for example, the one that I have up on the screen right now, y1, you have the tilde, you have ax1 cubed. Then
I
plus,
am looking with the first one, the one on the top.
First one, the tables.
oh, the tables.
Yes.
Wait, so what's the issue? You're saying nothing's coming up on the graph?
I have the dots, but not the lines.
Oh, because you got to do all the other stuff for the lines to come up.
Okay.
Yeah, the lines aren't going to come up until you regress.
Okay, yes. Thank you.
No problem.
So we just write out the ABCD values only for the equation that's closest to 1, right?
Correct. Yeah, we only use the winning equation. So then once you have that, you can handle it a couple of ways on Desmos because ultimately we have to plug in a value representative of the year 2017. So that means we're going to plug in the number 17 because it's years since 2000. So that part's okay. It's just getting this all into Desmos can be a little challenging, right? So what we would need to do is write this as f of x, and then unfortunately type all this stuff in. So the thing is, Desmos keeps track of the different parameters. So, well, before I do this, let me just show you. So if I type the number A, oh, it's confused now. Well, let me get rid of the ones that I don't need. Just wipe those out. If I type in the number A, and I'm saying number A even though it sounds weird because it really is representing a number, it brings up the value associated with it. So you have access to this information based off those parameters. The thing is, if there was a conflict with all the other regression models that were there because they've reused the letters A and B and in some other cases for more elaborate functions, possibly C, D, and E, and so on. So if you eliminate all the ones that didn't win the competition and just keep the winner, then if you type the letter A or the letter B or the letter C or the letter D, the corresponding decimal values will come up, right? So the benefit of that is I can type in f of x, and instead of writing long decimal x to the third plus long decimal x to the second and so on, I can actually just write a x squared plus, I'm sorry, cubed plus b x squared plus cx plus the d value. All right. And you'll know you did it right. I'll hit enter here to lock it in. You'll know you did it right if you turn off your function, your regression model, by tapping on that little circle, and the curve still appears, right? So it's there. They're both the same. You can alternate. You can kind of play around with it and see.
And that's
Turn it
only if you keep a single one of the equations as opposed to having the three that you were attempting to determine r squared for.
Correct. Yeah, you got to get rid of the other ones.
Okay.
Otherwise, it gets confused. All right. And then it's a simple matter of just typing in f of 17 to get your resulting value here. So I would say I'll just write it out kind of verbally. When x is 17, y is 2.866. All right, so we're talking about duration. It doesn't seem like observed durations of total lunar eclipses between blah, blah, blah. I don't see any measure of time. Maybe it's minutes. So, but this is the value that we're looking for.
Professor?
Hmm.
Sorry to make you go back, but I kind of got lost after you did the plugin. So on Desmo, I did the Y1 with the squiggly thing, and I got the parameters for A and B, but I got lost how you find out C and D, and I don't know where the X is 17 is coming from. So I got lost from that point down.
So you got this part?
Let's see what you have there. Do I have that? Yes, I have that.
Okay. So all I did was I rewrote the function
Okay.
just using f of x instead of y. I put in an equal sign instead of the tilde, and then just plain x's instead of the x1s, but leaving the a, b, c, and d, because right above it, they tell us what the parameters are, that the a is equal to that number, and the b is equal to that number, and the c, and so on. So that's just retyping the function.
Okay.
Then the 17 comes from the fact that in part B, when it says estimate the duration of a total eclipse in the year 2017, the X values are years since the year 2000. So 2017 is 17 years after the year 2000. So that's the number that should be going in for X. And the way we do that mathematically and in Desmos is we write it using function notation. Instead of saying f of x, I say f of 17. So if I needed to evaluate it for when x is equal to 30, I would say f parentheses 30. And then basically what Desmos is doing is it's plugging the 17 in everywhere there's an x in the function and simplify. And this is what it came back with as a result.
Okay. When I type in the function and I just switch the fx, it gives me like that little error on the side.
You type the whole function in?
Yeah, I've been looking at it I've been typing it since you've been talking. I had retyped it and I still get this error. So I don't know if there's something else that I'm missing.
And you have the A, B, C, and D and all that stuff. And you only have the one regression model there? Did you delete the other ones?
Oh, like the quadratic and another one?
Yeah, those have to go, otherwise it gets conflicted.
Okay, so that's the step that I missed. Okay. Oh, okay.
Nice.
I see. Thank you.
No problem. Okay, so that's an example of a regression problem. The last one, just for space, I kind of flip-flop. This one talks about regression equation and residuals. So Desmos is really good about that too. So let me save this. This is,
Professor,
yes.
I'm gonna like binge watch your YouTube videos today and tomorrow, but Is there any other equation that we should have saved in our Desmos like we do for the regression one?
No, because if you have all the regression stuff in there, then you have everything that could be relevant.
Okay, thank you.
Professor, which function we have to delete before going to the F function? You say quadratic and all of
And
the
exponential.
Okay.
So keep the cubic. So I'm just typing in the data for the next problem, the last problem. Oops. Spiraling out of control.
Professor, one more question.
Sure.
I also going to go to YouTube tonight and tomorrow, but for the test, it's okay to use our notes, the one that we are taking.
Yeah.
Well, the one that we did, like we have the last class perfectly all detailed, the quadratic formula and all the diagraphic information. It was amazing. So I'm wondering if we can use those.
On the Desmos?
No, in my notes, I write it down all your class when you lecture, but I mean, it's my own writing. And I
Oh yeah, that's fine too.
Okay, good, thank you.
So I just typed in the data. We need to come up with a regression model. So now this is supposed to be a linear regression equation. So that's a little typo there. All right, so this one's much simpler in terms of the regression. Y tilde mx plus b. Y1. See, I even make that mistake. But fortunately, Desmos, it kind of lets you know that you screwed something up and you go fix it. All right. So I put the appropriate values in. So now I'm good to go. For the linear regression equation, we could write it in the appropriate form of y equals mx plus b. We know that the m is 4.30909. You could round it, pretty significant if you want, but you could also put the whole thing. X plus 50.8182. All right. Now, this next little bit is pretty awesome, and also something I kind of wish, I definitely wish I knew about a week ago. But now that I see it, it's so obvious that I should have recognized that it was an option. You see where it says residuals, and below that there's a little button that says plot. If you tap that, it creates the residual plot. Yeah, I mean, if you remember all the time that we spent creating the table for the residual plot, then this would be a pretty aggravating moment for you, I think, because it's like, are you kidding me? We could have done that the whole time. If it makes you feel any better, and I don't know that it does, I had the same feeling. I was like, I could have been doing that the whole time. I could have the whole time. So yeah, it goes back and it pops in the residual values into the original data table, so that you don't actually have to create them. You don't have to construct it by hand. So that's pretty awesome. And also, I wish I knew that a week ago. So have some questions coming in. Tears were shed because of that plot. I don't see where it says plot. Luckily, I don't remember. Yeah, you blocked it out. That's what happened. It says plot. Well, it doesn't say it anymore now, but because I already tapped on it. But right underneath where it says residuals, it says E1, and then it'll say plot. Right, a little plot button right after that. So it's in the regression display. Right, so then we just need to get this information on paper. Now, on paper could mean many things, like you're taking the test. You could just submit this as your supporting work. And so you wouldn't have to handwrite any of this, right? And same thing with the graph. If you want to just paste the graph in, that's fine too, right? So it's construct the residual plot. If you want to do it by hand, you're welcome to do it by hand, but you could also just pop it right in there, right? So if you're going to do it using technology, then screenshots are going to be pretty useful, just so I don't have to deal with you know, your graph coming to me, and it, you know, the Zoom isn't really, not Zoom as in the meeting, but Zoom as in like how closely we're looking at the data, the plots. If that's out of whack, then I might not be able to see what you intend for me to see. So if you just do a quick screenshot and then just, or turn your iPad off. That's what I just did apparently. Great. There we go. Quick screenshot and just pop that in. You know, upload that. That's going to be the way to go. You know, just put that in a Word doc and submit that on Blackboard. Then you'll have everything you need. I mean, I think that's probably the most user-friendly way to go, because doing it by hand, as we discovered last time, is definitely not the most user-friendly way of handling it, right? So you just pop it right in there. You can kind of tweak it a little bit, resize. It's all good, right? And so once you have that, and again, the table, you could do a share link with Desmos to show me the actual data set, but you could also do a screenshot and paste that in also. All right, so this problem is not designed to be overwhelming. In fact, I kind of have it in mind that if people kind of get where I'd like them to be with this topic, that the response for this question on the test could just be something as simple as, here's my Desmos link, and you need to answer part D here, which is saying, does the residual plot above show a linear relationship, and how do you know? That part is, you know, the only verbal reply, but you wouldn't even really need to go too crazy with the file uploads, right? So this bonus is going away because I have another bonus opportunity in mind for you. But anyway, does it show a linear relationship? We say yes. Data is scattered with no real pattern. All right. If your residual plot actually showed a pattern, that would indicate that the linear model was not the best fit. So, you know, there's exceptions to everything, but that's the general rule of thumb. Making this look a little bit better. All right. And so, like I said, when you get these data points in, you just pop it right into your document and then upload that. It makes everybody's life a whole lot easier. All right. So looks like I got a question in the chat. Oh, okay. All right.
I have a really this is such a simple question, but I don't know what makes it linear.
If there's no pattern to the residual plot.
Okay, and then if there is a pattern, you say like positive and negative?
You don't even have to get into that. You would just say, if there's a pattern, you would say that it does not support a linear relationship.
Okay, thank you.
Yeah, no problem. These values, I can pop in. I'm missing one at the bottom, but I just handwrite it. But yeah, that's really, I mean, that's all there is to it. You know, I mean, easier said than done, of course, but it's, I try to keep my assessments from being overly mysterious. I'm not interested in that. I try to go for like, hey, this is what I want you to demonstrate that you know how to do. So as long as you do that, then you're in good shape, you know. And so this review checks all the boxes in terms of what I'm looking for in terms of your understanding of the content. And you know, like some things are obviously more challenging than others, but you see the pathway towards a good grade. All you have to do is, you know, I'm laying out the hoops. All you got to do is jump through them, right? So at this point, I'm going to stop recording.